So what we're looking at here is (100) confidence intervals that are made from 100 samples. Okay, so if we make samples and we look at them on a graph, this is what they all look like if all of them are there. So if you see in the middle of each of those lines, there's a dot. The dot in these lines is your X bar. It's your sample mean, and you've made a confidence interval for each one. So if I zero in on one in particular, I can just click on one or run over it. So this one, here's one with a mean in the sample of 43.252. Its lower limit is 35.06 and its upper limit is 51.443. And that's just one of them. And there's 100 of them drawn there. Some are from higher sample averages, some are from lower, okay? In this population, that line here is for the actual mean of the population is 50. So that's our mu in this population. And they've set it with a sigma of 10. So if you notice some of these confidence intervals are going to overlap that 50, which means 50 is in that confidence interval. So if I look at one again, here's one with a mean of 47, my lower limit's 41.29, and my upper limit's 54. So 50 is in between the lower and upper limit. Okay. But the red ones, the sample mean is high or low enough that 50 doesn't quite fit in there. So this one has an upper limit of 49.884, so 50 is just a little bit outside of the confidence interval. And as you can see, that happens for about 50 intervals using these methods. Okay. There's another one where 50 is just a little bit lower than this confidence interval. So 95% of the time, it's going to capture that mean that we're trying to figure out. But about 5% of the time, it's not. But it's not far away. We don't have an interval way out here somewhere. They're all pretty close to that confidence, to the actual mean of the population. Now, in reality, we don't know the mean of the population or we wouldn't be doing this. So we don't know what the mean is, but this method works to get about 95% of them if that's our confidence level. So what I want to do now is change that confidence level to be a number like 90%. So I want you to watch these intervals as I change it to be 90%. And we do it again. And those intervals, because we're willing to be wrong more, because we only need to be 90% confident, you have intervals that are further outside that 50, which means you can have smaller intervals. They can be smaller because you're willing to be wrong a little bit more. Does that make sense? If we want to be right, we need to get a higher number here. I'm going to change it to 99. And see how the intervals immediately got wider so that we have bigger, more likely to catch that 50 in the interval. So it's kind of a balance between, do we want to be right more often, or do we want to be more precise and be closer to that number? It depends on what you're doing. Okay. Now, if I go back to my options, I can also change my standard deviation. So let's pick a standard deviation instead of 10. Let's pick it to be 2. So we're going to have a skinnier distribution to begin with. And it's going to make me have smaller confidence intervals because my standard deviation is going to be smaller to begin with. All right. So the nuts and bolts of it. How do we do this? Let's do that next.